Hey guys, Mr. B here, and I thought I might just give you a couple of little, last little video, just a couple of problems on shaded area problems, shaded region, things like that. So here's a question, and it says, if the center of the circle is O, having radius 8, and AC is 7, so this guy right here, in triangle AOB, so AO is equal to angle A, AOB is 60, AO and OB here, or BO, is equal. Determine the shaded area. So basically what we have to do, so angle AOB, so this entire angle is 60. Diagram's a little confusing here. So what we have to do is basically use our knowledge of areas of sectors and our areas of triangles to be able to find the area of these two guys. So if you look here, here's our sector. So that's our part of our triangle, but we also have the big triangle here. So if we find the area of this big triangle and subtract the area of this sector, we'll have the area of this shaded region. So let me just get rid of this now. So let's find the area of the triangle first. So a really important formula to remember: area of a triangle is equal to and the one that we're going to be using exclusively here, for the most part, is 1/2 AB sine of C. So if you look here, this is our A, this is our B, this is our included angle. So you're basically just looking for a corner with two sides given and the angle in between. So it's going to be 8 plus 7, so it's going to be 1/2 times 15 times 15 sine of 60 degrees. So make sure your calculator is in degree mode here. So let's see. Sine of 60 is it's actually, well, hang on, my calculator's not in degree mode, so I didn't follow my own advice. Sine of 60 times 15 times 15 divided by 2. So the area of my triangle is roughly 97.4 centimeters squared. Make sure you got your units on a public exam. Mark's gone with no units. Then look for your area of your sector. So the area of my sector, hopefully you remember this guy, is equal to theta divided by 360. So this guy, 60 divided by 360, pi r squared. So r in our case is 8. So let me work out that. So 64 times 3.14 times 60 divided by 360. So it equals out to be 33.5 centimeters squared. So at this point you might want to check to make sure your numbers are okay. Got my units. So this guy is smaller than that guy, so that looks okay. So my shaded region, I'll call it just SR for short. It's going to be 97.4. Subtract 33.5. Do the math on that guy. 97.4 minus 33.5. You get 63.9. 63.9 centimeters squared. And that is my answer. So this is all that shaded region right here. Very typical long answer question, guys, to be able to do something involving these two guys, especially for 3204. Alright, let's check out another question. So if O is the center of the circle, having arc AB be 101, so AB, that's down here, this guy, and the radius is 5, determine the area of the shaded region. So stop this question, stop this right now and give it a shot, see if you can do it. Alright, so hopefully you've tried it, you've come back. So if this arc down here is 101, so we need an angle here. So we need actually this guy, 101 up here. So the measure of the arc is equal to the central angle. So we essentially have everything we need now. These are just radiuses though, so these are all 5. This is actually, if you remember, this is called a segment. So segment is equal to a segment up here, so we're okay with that. So what we can do now is we can do the math. So we can go figure out the area of this triangle right here, figure out the area of the entire arc, and then or sector, and then we can subtract them. So let's see. Area of the triangle, I'm just going to make a little triangle here like that. It's 1/2 5 times 5 sine of 101 degrees. So let me just check and see what that is. So sine 101 times 5 times 5 divided by 2. So we're looking at 12.3. And that's centimeters squared again. In the area of my sector, remember our sector is just like an ice cream cone. And this guy actually looked like it. The segment is the top on the ice cream cone. So it's going to be 101 divided by 360 times pi r squared. So r in this case is 5 squared. So 101 divided by 360 times 3.14 times 25. So that's going to be 22.0. We don't need a point there, I guess. So then if we want to find this shaded region, it's just going to be 22.0 minus 12.3. So keeping all my numbers in my calculator here so I can get a better estimate. So it becomes about 9.72361 repeating. So 9.7 I'll keep it as centimeters squared. So that is the area of just one segment. So this guy's 9.7, this guy's 9.7. So both shaded regions. So total, we're going to have to go 2 times 9.7. So times this guy by 2. I'm looking at 19.447. So I'll just go 19.4 centimeters squared. And there's my answer. So this is a typical shaded area problem, guys. There's lots of them out there. You might want to try a couple on your own there for practice. Good luck with your studying. I'll see you.